Hi everyone, in today's lesson we're going to talk about how to evaluate instantaneous velocity and acceleration and how to use integration to find displacement. So let's read through the first example. It says a particle moves along a horizontal line according to the standard position function x of t, where time is greater than or equal to 0, time is measured in seconds, and x of t is measured in feet. Given the velocity function below, I just put it over here, find the instantaneous velocity at 6 seconds, find the acceleration function, and find the instantaneous acceleration at 10 seconds. So all I'm talking about when I say the word instantaneous velocity is at that exact second. So at 6 seconds, what is my velocity? So all you would have to do is plug in 6 into the t here for the velocity to find that. So I'm going to do that over here and I'll label this part A. So for part A, all we need to do is find v of 6. So negative 3 times 6 squared plus 44 times 6 minus 105. So go ahead and type in all of this into your calculator, pause the video, and then hit resume when you're ready for the answer. Okay, so I got that v of 6 is equal to 51. So that just means my instantaneous velocity is 51 feet per second, if you want to be specific about the units. Okay. Part B says find the acceleration function. So the acceleration function we know is the derivative, so I'm just going to put this here, derivative of v of t. So if I have my v of t function, I just need to find the derivative. So my acceleration function, a of t, is going to be where I multiply the power with the number in front. That'll give me negative 6. Take the t and drop this exponent of a 2 down by 1. So it's just 6t. And then 44t, when I take the derivative of that, I just get 44. And then the last term, when I take the derivative of a constant, I get 0, so I don't have to add anything to it. So that's part B, that's my acceleration function. And then part C, finding the instantaneous acceleration at 10 seconds, literally is the same thing as before, except we're going to plug in 10 for t into my acceleration function. So go ahead, take a minute, type all this into the calculator, pause the video, and then hit resume for the answer. Okay, so you should have gotten negative 16. So the acceleration is negative 16, and technically this would be feet per second squared if you want to get technical about the units for acceleration. I'm not going to care too much about the units, but that's the idea behind that. Okay, so now I'd like to move on to another part. I'd like to call this part D, where I'm asking you to find the total displacement over the interval from 0 to 12. And the formula that we've learned in the past for displacement was to do x of b minus x of a given the interval over a to b using the x of t function. So this is the information that we've learned before. However, if you recall, the information that's given in this problem is v of t. So I'm just going to rewrite it. My v of t function was given as negative 3t squared plus 44t minus 105. So we must have another formula that we can use when finding displacement. And that formula is going to be the integral from a to b of v of t dt. When we are given the interval, same concept over a to b, but this time we're using our v of t function. So because our information was v of t, I'm going to solve displacement using this formula below. So we're going to integrate from the interval of a to b, so a is 0 and b is 12, of our v of t function, which is negative 3t squared plus 44t minus 105 dt. So we can do this one of two ways. We can do it by hand by integrating and then plugging in these two values. Or you could just type this whole thing into the calculator and get an answer. To be honest, I'm really not worried about doing the integration by hand. So just remember where this is to put all this into the calculator. You go hit the math button and then you select number 9. So I'd like everyone to do that. Take a couple minutes, plug it into the calculator, pause the video, and then hit resume when you're ready for the answer. Okay, so my final answer here, I got 180. So the total displacement for this problem is 180 feet, if you want to be specific about the units. All right, so I'd actually like to show you how you can get 180 using the x of t function. So how do I find x of t? Well, we know that the x of t function is the integration of the v of t function. So we're going to put all this in integrations dt. So let's go ahead and integrate the right side. So negative 3t, add 1 to the power, divide by that power, plus 44t, add 1 to the power, divide by that power, minus 105t plus c. So let's go ahead and simplify a bit. So negative t to the third plus 22t squared minus 150t plus c. So in order to find this c value, I had to have given you an initial condition like I did the other day, such as something like x of 0 is equal to 10, right? And you would plug in your x is 0 and your y is 10. But this information is not given. So we need to be able to still find the displacement the same without it. And we can. So remember that the displacement is still found by taking, so I'm just going to write displacement, is still found by doing x of b minus x of a. And this interval was from 0 to 12. So we need to do x of 12 minus x of 0. Okay, so I'm going to go ahead and plug in 12 into my x of t function. So x of 12, so negative 12 to the third plus 22 12 squared minus 105 12 and then plus c. So it's unfortunate, but that plus c kind of has to stay there until the very end. So I'd like you to type all this into the calculator, pause the video, and then hit resume when you're ready for the answer. Okay, so when you plugged it in, you should have gotten 180. And then we don't forget we need to keep that plus c. And now we're going to do the same thing, except we're going to plug in 0. So negative 0 to the third plus 22 0 squared minus 105 0 plus c. So you don't really have to put this into the calculator. Obviously, all of this is going to just be 0. So the 0 plus c is just c. So my x of 0 is c. So we're going to plug in two things and subtract them. So the first thing is 180 plus c, and the second thing is just c. So really it's just 180 plus c minus c. So the c's cancel, and the final answer is just 180 like we had before. Now, personally, I think when you're given velocity, this is a lot of work. I'm not sure that that's something that we need to do every time when we can easily just use the integration like I did on the previous page. All right, let's just try one more example. I want to find the displacement over the interval of 1 to 3 given this velocity function below. So I'm going to use the integration definition. So the displacement would be equal to the integration of v of t dt over the interval from 1 to 3. So I'm going ahead and write my integration of 1 to 3 of my v of t function, which is 3t squared minus 12 dt. Now you can solve this by hand if you'd like, or you can simply put this into the calculator using your Math 9 button. So pick a method, go figure out your answer, pause the video and hit resume when you're ready for the answer. All right, so I got 2. So our total displacement in this example is 2. Now I didn't specifically give you a unit, so you could just say 2 units, 2 feet, 2 inches, whatever the problem was given. But that would be our total displacement. All right, that's it for today. If you have any questions, please let me know.